Okay, let's look at the third one that I have here for us to graph. Recalling our previous information that we found about this function that we determined for this function. We determined a vertical asymptote. There was none. We determined a y-intercept was at 0, 3/2. We determined an x-intercept at -6. And we determined that it had a horizontal asymptote at the x-axis, y = 0. Let's map that out before we go to a calculator. No vertical asymptote. I've got a horizontal that's running right here along the x-axis at y = 0. So there's my horizontal asymptote. A y-intercept at 0, 3/2. I'm going to mark that here, 1.5. We'll call that 1.5. And an x-intercept at -6. So we'll put that here. Remember I said your graph could cross a horizontal asymptote, but it can't ever cross a vertical asymptote. Here's a case where your graph crosses the horizontal asymptote. When it crosses, it's just going to happen. So here it's crossing. And now this is kind of interesting. The points that I have here in the asymptote, let's see what's happening graphically with that. Let's clear it out and let's start with some parentheses. X + 6 divided by x² + 4. And let's just go to Zoom 6 and see what that looks like. Kind of looks like a little ant hill here in the middle. Let's go to Zoom 4 and just get a better idea of what's going on there. Okay, so it's making this little hill thing. It's going out to the right, and to the left it's closer to that x-axis than it is on the right. I'm curious what this high point is. I don't think it's that point, the 3/2. So let's go ahead and do second calc, and let's calculate that maximum. That would be a left bound. Let's go to the right. Give it a right bound. And it says that maximum is 0.32 and 1.54. So that's my high point. Let's see what happens to the left as we trace it and go to the left. Let's see what happens at the -6. So notice I'm still riding above the y-axis. My y values are positive. That means I'm on top of the positive values on the y-axis. Let's see what happens as we get closer to -6. I'm still above the y-axis. Notice at -6, it's on the y-axis. And when I go beyond it, it's below it. So what happens is our graph goes to the -6, crosses over, and then it's going to ride right below that asymptote. Can't really see it very well, but it goes, crosses at 6, and then just rides right below it. So let's see how we can graph that. Interpreting what we saw on our picture, this 3/2 wasn't the high point. It actually came up and had a higher point right beyond that, and then came down. Now this side's going to ride right above the horizontal asymptote. This side is going to cross over and then ride right below the horizontal asymptote. So that one's kind of tricky. And my graph isn't perfect. Obviously the calculator gives us a better rendition of that, but it's so important to figure out what's going on right there at that point where it crosses the horizontal asymptote. So let your calculator help you determine where to place your curves and how to interpret those. Finally, let's look at an application. An interesting model here, it models the pH level of the human mouth. And what it measures is how many minutes, or it measures the pH value of your mouth X minutes after a person eats food containing sugar. So let's take a look at this graph. Okay, here we're at the 0 mark. And at the 0 mark, this tells me the basic pH level of the human mouth. Nothing has happened. It's just normal. You hadn't eaten anything. 6.5. Well, that's what it looks like to me anyway. Then it says you're going to eat some food containing sugar. So after 6 minutes, you've eaten some food containing sugar. What happens to the pH level? The sugar causes the pH level in the mouth to drop. After about 6 minutes, it gets to its lowest. Then the mouth begins to recover and works on getting back to its normal state. So we're going to consider this normal, the normal pH. So it dips low and then it starts to recover. Well, let's use the graph to get a reasonable estimate to the nearest tenth of the pH level of the human mouth 42 minutes after a person eats food containing sugar. Well, here's the 42-minute mark. It's 42 minutes after a person eats sugar. If I come up here, what do you think the pH level is? Well, at 42 minutes, looks to me like it's right at the grid mark for 6.0. So 6.0. Let's look at the graph and answer the next question. After eating sugar, when is the pH level the lowest? So how much time has passed when the pH level dips to its absolute lowest? Right here, after 6 minutes. So when is the pH level the lowest? After 6 minutes. It says to use the function's equation, so let's use the model that they gave us to determine the pH level to the nearest tenth at this time. Well, I'm thinking after 6 minutes the pH level is going to be somewhere around 4.5, between 4.5 and 5.0, maybe 4.7, 4.8. I'm estimating that from the graph, but let's actually find it from the function. Okay, let me get that function up here. And we're finding out what's happening at 6. So let's just go to a clear screen. Let's use our parentheses. And it's going to be 6.5 times the number we want. We're putting in 6 minutes. 6 squared minus 20.4 times 6 plus 234, and it's that quantity divided by x squared plus 36. 6 squared plus 36. So we're testing to see if this model gives us an accurate value of what we expect, between 4.5 and 5.0. 4.8. So after 6 minutes, the pH level seems to be the lowest, and the lowest value that the model gives us is 4.8. So use the function's equation to determine the pH level to the nearest tenth at that time. So that is 4.8. According to the graph, what's the normal pH level of the human mouth? Well, it's what we had set up here. Initially, the mouth has a pH level of 6.5. Then we see it get low and then again start to recover over time. So I would assume the normal pH level is 6.5. What's the equation of the horizontal asymptote associated with the function? Let's look at it. We've got our graph dipping down, and notice as a slow recovery. What would you expect the horizontal asymptote to be? Well, I'm thinking if it's recovering back to normal, the horizontal asymptote would be here at 6.5. Y equals 6.5. That means the mouth's pH level over time will recover back to that normal 6.5. And we can look at the graph. We just discussed what happened, but let's look at it to describe what happens to the pH level during the first hour. So during the first hour means we consider from here to here. And during the first hour, what happens? The pH level dips rather quickly, but then over time, it begins to recover, and it works its way back to eventually that normal pH level of 6.5. Use your calculator when you're graphing these problems. The book will, the exercises will have you plug in some points, which is fine. I do want you to do that part of plugging in points, but I also want you to use your calculator to help you determine how to place your curves. So there's some technology problems, application, technology, and some critical thinking problem that I'd like you to look at in this section. And that should be it for Chapter 3.